Hello everyone. Today's video is about exponents. Are you together? Uh, Today I'm focusing on exponents. Yeah, so slow. Exponents. Okay. Uh, before we check before we even check the laws of exponents, let's first define our things. If you have something like this, please note that our a, it will be the base of the number. This thing will be the exponent. Are together, and when they are combined like this, it's called the power. Are together. Before you even deal with exponents, let's first start to check their laws. Are together. The law number one of exponent, law number one, simply states that if ever you're multiplying bases that are the same, you just take one of them and then you add your exponents. For example, if we have 2, the examiner would say 4 multiplied by, let's say, 16. This thing will be 2. 4 you can write it as 2 squared. 16 you can write it as 2 to the power 4. Just take one base and then you add the exponents. You'll get what? 2 to the power 6. When you punch 2 to the power 6, you'll get what? 64. Right, together. So if ever multiplying two bases that are the same, you can just take one base, then you add your exponents. Please pause the video for 2 minutes and then do this example on your own. 3 multiplied by 27 without using a calculator. So you got 3 multiplied by 3 to the 3, nah? So whenever you have a number like this, just a 3, just know which its exponent is 1. If the exponent is 1, we don't need to write it out together. So if you don't see an exponent, just know that there is 1 there. So this exponent is 1. We are multiplying bases that are the same, so we'll just add the exponent. We'll just take the 1 from here, and then you'll add with the 3. What do you get? 3 to the power 4, and then 3 to the power 4 is 81. Are we together? So on the first law, just know that if ever you are multiplying bases that are the same, just take one of the bases, add the exponents. Are we together? Then let's go to law number 2. Law number 2. Law number 2 states that if ever you are dividing bases that are the same, it's cool. Just take one of the bases, then you subtract the exponents. Are you together? The first one minus the second one. So in this case, it will be the numerator over the denominator. Sometimes you can be given it like you can be given something like this: a to the power m divided by a to the n. That's why I said it's going to be the first exponent minus the second one. Okay, so example, you will have, let me say, 64 divided by 4. 64 divided by 4. 64 can be written as 2 to the power 6. 4 is 2 to the power 2. Right, together. Then if you are dividing bases that are the same, simply have to say 2 to the power 6 minus 2. You'll get 2 to the power 4. And 2 to the power 4 is what? Is 16. Are you together? So do example as well. Just do let's say 1000 divided by 10. Just pause the video. Okay, I'm assuming that you got 1000 is the same as 10 to the power 3. all over 10. This thing is 10 to the power 3 minus 1. 10 to the power 3 minus 1 is 10 squared, and 10 squared is equal to 100. Right together. So this is how you solve it using exponents. Because I know maybe from grade 4 you just taught to do this. Then I left it 100. Hey. Okay. And then law number 3. Law number 3 simply tells us that exponents and powers, they multiply one another. If you have a to the exponent m all raised to the power n, it will say a to the power m multiplied by n. For example, if you have 3 like this thing is the same as saying 3 to the power 2 times 2, which is what? 3 to the 4, and 3 to the 4 is what? Is 81. Are you together? So on your own, just do this example. Okay, so this thing will be 2 to the power 2 multiplied by 4. 2 multiplied by 4 is the same as 2 to the power 8. 2 to the power 8, 2 to the power 6 is 64, to the power 7 is 128. Then 2 to the power 8, it will be 256. Are we together? So whenever you have an exponent in the power, just know that those two things, they will multiply one another. Okay, and then we move. So the first three laws, they are called the first base, the same base laws, ne? Let me write here. Same base laws. Then we have a to the power m divided by a to the n is the same as a to the power m minus n. Okay, these are the same base laws, are we together? And then now we move to the other ones. Law number 4. Law number 4 simply states that excuse me. Law number 4 simply states that if you have different bases, for example, like taking from law number 3, no? All raised to the power x, we can just this x will become the exponent of the first base and the exponent of the second base. So it will be a to the power x multiplied by b to the power x. For example, if you have 2 multiplied by 3 all squared, it's the same as saying 2 squared multiplied by 3 squared, which is 4 multiplied by 9, and you'll get 36. All together. So if you have two different bases multiplying and there's one exponent that accommodates both of them, just know that exponent will be the exponent of the first base and the second base. Sometimes it can be even 4 bases. Doesn't matter how many bases you have. Sometimes it can be even 4. Sometimes you can have a multiplied by b, c, all raised to the power x. a to the x, b to the x, and c to the x. As long as they're multiplied, you are allowed to do this all together. Okay, and then going to the fifth law. Going to the fifth law, we can say that if ever you're dividing two things that have the same exponent, if you're dividing two things that have the same exponent, you can write them like this, because they have the same common exponent right together. For example, if we have like this, I can write it as 3 to the power 4 divided by 2 to the power 4, which is what? 81 over 16. Are we together? This is 81 over 16. Moving from the fifth law, I can use exponents, rather sets, because we are dealing with the same exponents. Né? If you have something like this, you have two things dividing under one root. That means they have the same exponent. Né? So we can just write it as square root of a over the square root of b. Right, together. For law number 7, if they are multiplying, you can do the same thing as well. Square root of a multiplied by the square root of b. Right, together. Examples for both. If I have the square root of 16 over 9, I can write it as the square root of 16 over the square root of 9, which is 4 over 3. For this one, I can write this the square root of 100. I can write it as what? 25 multiplied by 4, which is 25 multiplied by 4. Just separated the two things which are multiplying under one square root. Can you see that? The square root of 25 is 5, the square root of 4 is 2. Then I'll get 10. Alright, together. So this is how you deal with numbers under one vertical sign, whether they are dividing or multiplying. You deal with them like this. Alright, together. Please don't do this here. If you have a plus b, this thing is not equal to the square root of a plus the square root of b. Yo, and then since we are dealing with sets, let's go in this one. If you have a x like this thing can be written as x to the power b over a. Please note that your root is always the denominator of your exponent. If you have something like this, the cube root of 9, for example, we know that 9 can be written as 3 squared, right? So it will be like this, 3 squared. So this thing will be 3 raised to the power 2 over 3. Please note that this 3 is the same as this one. The denominator of your exponent is the same as is equal to the root of a number. Alright, together. if you have something like this and you want to make it to if you have a number like this, just know that if you remove a term from the denominator to the numerator, the only thing you have to do is to change the sign of the exponent. So here I'm moving this a to the power p from the denominator to the numerator. The only thing I have to do is to change the sign of its exponent. All together. For example, if I have 1 over x squared, yeah, you'll deal with this a lot whenever you do calculus. I want to take this x squared and put it at the top. What must I do? I must just change the sign of its exponents. All together. Sometimes you will have a number which is not 1, like this. Maybe let's say x to the power 4. This is the same as taking the 3 multiplying with 1 over x to the power 4. So you'll just say 3 multiplied by x to the power negative 4. You can just move from here to here. There's nothing wrong. All right, together. The most important thing I want you to know is that anything raised to the power 0 is equal to 1. All together. Anything raised to the power of 0 is 1. Even if you can have 1,000 to the power of 0, you still get 1. All together. Okay. Now we know the laws. Let's learn how to use them. Let's learn how to use them. There are different ways in which we can use these laws. All right, together. For the first part of it, please note that if your terms are not separated by a plus or a minus, all you need to do is to change everything to have the same base. To the same base or same bases, and then secondly just apply the laws. How so? Let's say we have 18 raised to the power x multiplied by 2 all multiplied by 3 to the power 1 minus x all raised to the power 2 all over 2 to the power x minus 1. There are no plus and minuses subtracting the terms here, but you have plus and minuses subtracting exponents. That's fine, you can leave it. So all we need to do is to just make bases to be the same, to change all bases to have the same base or the same bases together. So we already have 2 and 3 which we cannot change any further. So that means we must change 18 to have a 2 and a 3 as well. How can we do so? I know that 18 is equal to 2 multiplied by 9. 2 multiplied by 9 is the same as 2 multiplied by 3 squared all raised to the power x. All together. And here I have I have two things multiplied and the exponent there outside. This exponent will become the exponent of the first number and the exponent of the second number. How so? I'll have 2 to the power 2 multiplied by 3. I'll have minus 1x squared like this, all over 2 to the power x minus 1. Are we together? So now I can remove brackets here. I have 2 to the power x multiplied by 3 to the power 2x multiplied by 2 squared multiplied by 3 to the power 2 minus 2x, because exponents and powers, they always multiply. This is 2x minus 1. Okay. There at the top, now I can apply my exponents. I have same bases there at the top, same bases of 2. So and they are multiplying, so I can have x plus 2 because they are multiplying one another. Are you together? But the bottom the bottom part has the base of 2 as well, and the bottom part is dividing the bases that are on top. So I will subtract the exponent of the bottom part because it was dividing. Remember that if you multiply bases that are the same, you add exponents. But if you are dividing bases that are the same, you subtract the exponents. So that's why I subtracted x minus 1. So but for 3, the 3's are both on the numerator, so they're multiplying one another. So this is 2x plus 2 minus 2x. This thing is the same as 2x plus 2 minus x plus 1 multiplied by 3. These two will subtract one another. Then we'll be left with 2 here, and then here we'll be left with the x's will subtract one another. We'll be left with 2 plus 1, which is 3. This is the same as 8 multiplied by 9. 8 multiplied by 9, I believe, is there. So this is how we use the laws. If ever we don't have plus and minuses separating our terms, this is how we simplify the laws. Are you together? If you don't have plus and minuses if there are no plus and minuses separating our terms, that's how we do it. Here's another one. We have 2 squared multiplied by 4 squared, all raised to the power 1 over 6 over 1 over 9 divided by 6 squared over 8. Okay, this thing that is inside the brackets, it's 2 squared multiplied by 2 to the power 4. Why am I saying it's 2 to the power 4? Because if I have 4 squared, I can write it as 2 squared all raised to the power 2, which will be 2 times 2, and then I'll get 2 to the power 4. So I just move from here to there, and then I've written it there. All right, together. This thing is divided by 1 over 3 squared, all divided by 6 squared over 8. Here I have two bases multiplying. That means I must add the exponent. 2 plus 4 is 6, right? This is minus 1 over 6. And then I have 3 to the power negative 2 multiply. If ever you want to change the sign from division to multiply, you must flip the number on the right hand side. The 8 can be written as 2 to the power 3, and then I have 6 squared here. Alright, together. So here, whenever this 6 multiplies with the negative 1 over 6, I'll get a negative 1 rather, all over multiplied by 2 to the 3 . The 6 you can write it as 2 multiplied by 3 all squared. The aim is to have the same bases. Now all the bases I have the bases of 2 and the others of 3. 2 to the minus 1 over 3 to the minus 2 multiplied by 2 all over 2 squared and 3 squared, like this. The bases of 2, the ones that's at the top, they are multiplying one another, so I'm going to add the exponents. And the one that is at the bottom, this one is subtracting, so I'll have something like this. The bases, both of them are at the denominator, so when I move them to the numerator, they will change their signs. The first one is negative 2, it will become positive 2. The second one is a positive 2, it will become a negative 2. So here I will have 2 to the power 3 minus 3. So already I have 2 to the power 0 multiplied by 3 to the power 0, which is 1. So whenever you have bases that are the same, whenever you have terms multiplying or dividing and there are no plus and minuses separating them, all you need to do is to make the bases to be the same. Let me do the third example. 5x plus 1 multiplied by 25x minus 1. This is 125. Okay. Here I can change everything to have one base. Already for this one I cannot change, but I can change this one. This is 5 squared. I'll have x minus 1, and then at the bottom 125 is the same as 5 cubed, all raised to the power x. All together. So I'll have 5 to the power x plus 1 multiplied by 5 to the power 2x minus 2 all over 5 to the power 3x. This guy here will give me 5 to the power x plus 1 plus 2x minus 2 minus, because it's dividing, 3x. Then what do I get? I'll get 5 to the power 3x minus 3x minus 1, because 1 minus 2 is minus 1, né? So I'll get 5 to the power negative 1, because the 3x's will cancel. Then I'll get 1 over 5. This is how you deal with exponents if ever you have plus and minuses separating them out together. Okay, so now let's check if we have a plus or a minus separating our terms. If we have a plus or minus separating our terms, the first thing we need to do must separate the exponents. When I say separate exponents, I'm saying mainly focus on the first two exponents. This one that says a to the power if you have a to the power m over a to the power n, this is the same as so this for these things, guys, it's simple. For this is simple, yeah? If you have one base and then you have exponents which are adding, you can just separate them by using the first law of exponents. Just take one base, just take both bases and put back the exponents there. If you have something like this, just separate it like this, together. If you have things, if you have numbers subtracting the bases, I'll just take the first thing we need to do is to separate the exponents. Now I want to solve without continuing, without writing everything. The first thing, you must separate exponents. Secondly, you must factorize. You must factorize if you can. If you can't, use K method. Use K method substitution and then simplify. Those are the 3 steps we need to follow. Okay. Let's do the first one here. We have a to the power x plus 3 plus 2a to the power x plus 2 all over a to the power x plus 2a to the x minus 1. The first thing we need to do, separate exponents. I will have a to the power x plus 3. I'm writing the same thing. If I had a to the power x plus 3, that means I was multiplying my exponents since they are adding one another. Together, plus 2 multiplied by a. Here my exponents were adding as well, so that means they were multiplying, all over a to the power x plus 2 to the power. Here they are subtracting. It simply means that my bases were dividing one another together. But whenever I deal with fractions, guys, I don't want to have fractions within a fraction. That means I must remove this guy. How can I do so? If I multiply the top and bottom by the same thing, there's nothing I'm changing because a over a is 1. Together. I just want to multiply everything on the numerator by a and everything on the denominator by a. This a is our LCD. So what will I get? I will get a x and a to the power 4, because a cubed times a, it will be a to the power 4. The exponents will add one another together. So here I'll have 2 to the power a, and then a to the power 3, because 2 plus 1 is 3. These two things are multiplying, so the exponents will add. In this case, I will have a to the power x multiplied by a. They will just multiply one another, and on the other part I will have 2 to the power 2 times a to the power x, because the a's will just cancel. Now I don't have fractions within a fraction. I can work properly. What's common at the numerator? A to the power x is common, as well as a cubed is common. Together. And when I take out a common factor, I'll be left with a here and then a 2 there. On the denominator, what is common? A to the power x is common. Then I'll be left with a and 2. These two things will cancel one another. And then I'll be left with, let me cancel with a different color. Then I'll be left with what? A cubed. Alright, together. So whenever we deal with whenever we have plus and minuses separating our terms, this is how we solve these things. Alright, together. When there's a plus and a minus separating one another. Let me show you how to solve exponential equations when you have a plus and the minus. Whenever you solve equations, it's the same thing. Separate the exponents, use K method if you cannot factorize, and then solve. Alright, together. How so? If you have, let me see my exponential equations. What do I have here? Let's take the first one. I have 2 to the power x plus 1 minus 2 to the negative x plus 2 minus 7 is 0. Alright, together. I have plus and minuses separating my terms, so I need to separate my exponents as well. So I'll have 2 to the x multiplied by 2 to the power 1. This thing is and then minus 2 to the power 2 all over 2 to the power x. Because the x is negative, that means this thing was dividing. Right, together. Minus 7 is equal to 0. This thing can be written as 2 multiplied by 2 to the x minus 4 over 2 to the x minus 7 is 0. Then I can say let 2 to the x equal to k. So I'll have 2k minus 4 over k minus 7 is equal to 0. Right, together. So here in this case, I'll have, whenever I have exponents, not rather exponent fractions, the first thing I must do is to remove them. And I'll multiply everything by the LCD. But since I have a fraction, my restriction is important. K must not, whatever thing that I find as a solution, K can never be 0. Because if K is 0, this entire thing will be undefined. Okay, if I multiply everything by K, I'll have 2k squared minus 4 minus 7k is 0. This is 2k squared minus 7k minus 4 is 0. Then now I need to factorize this guy. Please, if you're still struggling with factorization, go to the first lesson and learn how to factorize. The first lesson, please. This thing is k is equal to this, or k is 4. Since I'm dealing with exponents, guys, 2 to the x can never be equal to a negative number. There's no value of x that I can substitute here in space of x and get a negative number. So whenever you have things like this, there's no solution altogether, but here we can find a solution because 4 is 2 squared. When the bases are the same, it simply means the exponents are equal. Are you together, guys? So whenever we have plus and minuses separating our terms, this is how we solve our equations. Please, guys, stay tuned, wait for more videos whereby maybe I'll do more questions on exponents. Yeah, and please follow me on TikTok, Best Academy 2023, where I post everything math related.